Welcome to section 4.1.1. We're starting out this chapter looking at patterns in slope triangles, and also by the end of the chapter we hope that we can connect it to similar triangles. Some of the big questions: how can the slope of a line help you? And what relationship exists between different slope triangles on the same line? We started this unit by looking at this particular problem where they asked us basically, what can we tell from this? The question basically said that if the lean or the slant of the Leaning Tower of Pisa ever were to drop below 83 degrees, that they would consider it dangerous. And so they asked us if we could find that. In looking at this image, we discovered that we could not, that there were things we could tell. Knowing these two sides and knowing that it's a right triangle, we could find this third side by doing 5 squared plus 50 squared equals c squared, and then basically solving in that process for that side. So there we could find the side that's missing, but we really couldn't tell what that angle was. And so they had us draw some slopes on, and they had us draw some slope triangles. Now you may remember from Algebra 1 what a slope triangle is. It's basically a triangle that shows us the rise over the run. Now, they've drawn us one here already. And they've shown that if I go from this point here on the line to this point here, that it goes over 5 and up 1. Remember that when you have a slope triangle like that, you write its ratio by the vertical change, or the rise, which in this case is 1, over the horizontal change, which in this case, the run, which is 5, which gives us a ratio of 1/5. They asked us to draw 3 in total on the line, and so we're going to draw 2 more. I'm going to do one that starts at the same point, and remember we have to stay on the grid lines, can't go off, so I'm going to go over, and I'm just going to go 1, 2. Looks like I've got another place here, so I can go to right there. And this new triangle that I have will also be a right triangle, and it will have dimensions of 10 and 2. So I'm going to draw or write its slope ratio, 2 over 10, which will reduce to 1/5. We can also draw another one. I'm going to draw one from this point. Let's see where the next natural place on the line is. It would be that, but that would give me one the same size as one I already have. So I think I'm going to go to right here. If I do that, I get a new one. It is 3 tall, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 wide. I'm going to draw its slope ratio down here, 3 over 15, which will also reduce to 1/5. So we see, if you might remember this from Algebra 1, that the slope of a straight line doesn't change. And so if I draw a smaller slope triangle or a larger slope triangle, I'm always going to have the same slope. Now the question that I'm going to ask now is, are these slope triangles similar? In other words, is there a way we can connect it? And we learned a couple ways we could do that. We could do it with angle-angle similarity, side-angle-side similarity, or side-side-side similarity. Since I don't really have 3 measurements, although I could use the third side, I'm going to do it this way. I know that this angle is going to be the same for both of the smaller triangles. Because it's the same, I have one angle that's the same. They also have a 90-degree angle in both of their corners, so I know that those two are similar by angle-angle similarity. The nice thing that's going to come out of this, that we're going to see, is that we can draw a conclusion that if two triangles are similar, and they have the same angles. In other words, there's a little one there with an 11-degree angle, and then there's a larger one there with an 11-degree angle, that they're going to have the same ratio, whereas this one may be 1 and 5, this one was 2 and 10. And both of those are going to have an 11-degree angle, and the ratio of their sides is 1/5. So here's the big picture for this unit. If two triangles have the same angle, and we're talking about right triangles and they're similar, then the ratio of their sides will reduce to the same number. And so our conclusion is that if a right triangle has an 11-degree angle, that its ratio of these two sides, the change in y and the change in x, are going to equal 1/5. Okay, now we went through and we drew some other triangles. Let me see which other ones we have here, if there's some that are particularly interesting. That's the only one. Well, there's one other one that I want to cover, and basically what they did is they took and drew the same, not the same line, but I'm just going to do it here. They said, what would happen if you drew a triangle that had a slope ratio of 2/5? In other words, I go over 5. I'm going to start right here. 1, 2, 3, 4, 5, and this time went up 2. So over 5 and up 2. Now, I've done a good job on this, and I used my protractor, and I'm going to find out that the angle on this one, that angle formed there, right there, is going to be 22 degrees. And so we would say that similar triangles that have a 22-degree angle, that those right kinds of slope triangles or right triangles, that their dy, delta y over delta x, is going to reduce down to 2/5. Now, we didn't do a whole lot with them. We just did some exploration in these, and later on we will do some more solving, but that is all we're going to cover for this unit. Hope this helps.